Yeah.
Hey guys, and we're live. This is Jan from DoraHacks, and welcome to the workshop number 10. Super exciting. So today is about anonymous voting using CK proofs. Before we start today, let me give you some more background of this hackathon. As the largest Web3 multi-chain developer incentive platform, it's an honor for DoraHacks to support the Grant Factory hackathon presented by Taiko. And we're looking forward to all the incredible and amazing projects building on top of Taiko. Today, we're very happy to have Swarnabha, DevRel at Taiko Labs. And without further ado, I will pass it over to Joran. And for the audience, if you do have any questions, feel free to drop them in the comments section.
Thank you so much, Jan, and thank you again to the DoraHacks team for supporting us and helping us do this amazing hackathon. If this is your first time hearing about us, I'm excited that you're here. We are coming to the end of our workshop and talk series, but we still have just under 30 days left in the hackathon submission period. So after this workshop and talk series, we're going to move into the grant writing and feedback phase, where you're going to be able to submit your grant, get some feedback, polish it up so that on the final day you're ready to go. And that is the general purpose of this hackathon. It's hacking, but also building a grant so that you can get some funding initially as being one of the top projects that come out of the hackathon, but then B, you're going to be able to unlock additional funding for your project, additional runway based on the specific needs of your project that will carry you out for 2, 4, 6 months down the line. So we really want to inspire and empower you guys to build businesses and deploy them on Taiko. And we want you to think about long-term sustainability. And so that's why throughout this workshop and talk series, we've given you technical support as well as entrepreneurial support, as well as just general grant writing support and business building support in the Web3 space. And so if you are coming into the ecosystem now, you can take a look back at our past videos to get all of that knowledge and support and through our past workshops, and build your project now, because you still have lots of time. And without further delay, I'm going to jump into today's workshop, which is talking all about voting on chain in an anonymous way. And it seems quite appropriate that in today's political landscape, that voting and voting security is a very important topic. We're going to look at a blockchain kind of view of that and what technologies we can use to secure these kind of voting systems. And when we say voting, also it can be anything from political voting to voting on whether hot dogs are actually sandwiches or not. And we don't want anybody to know what your vote is when you make that vote. So without any further delay, let's pass it over to Swarnabha and to take it away.
Hey, hi guys. So welcome you all again. Thanks, Jorin. Thanks, Jen, for setting it all up. And I guess you might have seen me quite a while now. So it's good to be back again. And I'll be. This is one of my last workshop in this Grand Factory, and honestly, I'll be missing this. This continuous rush of building different things for the audience, and then prepping all those things and continuously screaming in front of the screen for 1 hour or so. But yeah, it's been a hell of a journey, and I'm really looking forward to the projects which you guys submit, because this is something I have been really interested, and personally being a developer and seeing hackathons and participating as well. I guess one of the very prominent thing for me is to see different kind of projects and different, like, I feel hackathons are the best way to see how the projects are and how the things are and things like that. So yeah. Uh, so, so yeah, let's see. Uh, just a second. I think yeah. So let's get into it, and yeah, let's get started. So today's project is all about building a very private way to uh, to uh, to vote. Actually, I think there is some internet delay. Uh, um, just a second. Yeah, let me share my screen. Uh, yeah. So this is a project to actually actually a way to I guess my screen is visible now. So I have covered DeFi. I've covered some gaming stuff. I've covered some how you can pay. How I've covered some kind of some different types of things. But this is the last I thought, maybe ZK or ZK proofing can be used or can be, helped helped to show different people how you can actually make a very, very simple ZK project using let's say Taiko network or testnet or mainnet, anything. But I think, yeah, so let's get into it, and I think, yeah, let's jump. This is a very simple project. I have used ZK knowledge to actually just like enter an input, and then actually showing if it's without and revealing the result without even actually revealing what my input was. So as Jorin said, there is a lot of use cases on privacy and ZK and how you can make things, but I think one of the crucial thing is to like to build it right. Like we have heard a lot about ZK or anything else, but building on it is very crucial. So this is a very small project where you actually can use this and build a lot of things. So let's jump into it. As discussed, this is like I've used JavaScript like every other project. For the contracts, I have used Solidity, and yeah, I've used a external library so that you can actually use that as well. So yeah, let's get into it. So I have basically used Socrates. So this is a basically library which you can use to generate proof. You just don't need to do anything. Just install this, and everything will be set it up already set up on your local. And yeah, so yeah, let's get started. I think first, basically, before jumping onto ZK Snark, which I have mostly used on in my project, I think it should be a good thing to give a small brief about it. So what ZK Snark is actually, it's zero knowledge succinct non-interactive arguments of knowledge. Okay, a lot of words, but I think what actually it means is it actually means when the proof is not very big. Let me go. Yeah. So snarks is basically succinct non-interactive argument of knowledge. So basically it means is succinct means the size of proof is very small. You don't need to prove a lot of things which we are actually doing here. It's very small. And non-interactive basically does not require rounds of interaction between prover and verifier. Argument, we consider it secure only for provers that have bounded computational resources. Knowledge sound, so yeah, so Snark system can be further equipped with zero knowledge. So basically, which is what we have actually done. So this is like, if you go into very depth, it's a very complex thing. Like we don't need to do it in scope. So let me quickly go through the flow. So what here it is done is you basically input a number which is even or odd, right? So we all know even number is divisible by two and odd is not, right? This is a very simple concept. So what even is like, you can just see here, like you input a number which is, and then it generates the ZK proof for it, and you don't need to worry about it. It just generates with the library which we are using. Step 2 is it creates a verification key and proving key from the program, which I will show you. Third, it is created. Third is generate smart contract from verification key. And the fourth is like, and then it deploys. Here I've just added Ethereum, but you can I've used Taiko as well. Then so yeah, it then send the proving key, and then what happens is the voter generates witness with the program. You, this is not in our scope. I've just added in, which I will explain how what you can actually do it in future. And then the step 5 is generate proof with using witness and proving key. So yeah, this is the whole concept of the thing. So proving key is for encrypting vote, verification keys for encrypting the program. Smart contract verifies this vote is legit and update the result. And yeah, so let's go into the contracts. Let's go into the uh, 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 yeah, scripts first. I think there is not much script. This is the deploy script. If you have users again, I've used again hardhat, which is what I've been using. Like so deploy script I've used. So deploy is basically used. So like yeah, basically it's used to deploy the contract which we have written. The source, basically it contains all the pages. We just have one single page, very simple UI. So yeah, it just the index. So yeah, this is what the index is. First is the home page. It just have a single page, so you don't need to worry about anything. So yeah, like this prover key string, program string. Just a second. Yeah, I think yeah. So basically, use state basically provides like vote result, set vote result, and yeah, it uses even or odd. It actually takes it. So here, if you see, it does not take any input. That's the whole point. So no one knows what's your input or what's your, what is something you voted for. So like, this is amount. This is the same but set amount, and yeah, it basically request account. What it does is I've explained here. Just a second. I think, yeah. So this basically does is it actually what it does is it just requests the vote to be published on chain. So yeah, it basically compute by calculating is if it's even or odd. I've just created, yeah. Here it is does it request account. I will zoom it a bit. So yeah, await request account, and then using witness and proving key provided by verifier. What it does is, here I've already used proving key. You don't need to do anything. You just use that library and you can do it very easily with that. And yeah, you submit transaction to the blockchain, and yeah, it basically uses zk snark. And again, you can just do with this library. And so yeah, uh, let's go to the contracts. This is a simple contract for token. As you know, hardhat automatically generates it. So yeah, basically this is the contract. When you install hardhat, it automatically does it. This is the circuit. This is an important part. Okay, so this is the single contract which is most used by us. What it does is I will explain you one by one. So let's get just yeah. So I've created this explain as well. So what it does is it verifies using the verify function. Uh, just a second. Yeah, this is the verify function which is being used, and yeah, the verify function is responsible for validating ZK snark proof, so which confirm that a vote is legitimate without revealing any additional information about the vote or the voter. So what it does is the verification process ensures the privacy and security by checking the input. So So this is what actually takes input. So this is an array representing just a second. So this is an array like representing the public input to the zk snark. So it, in our case, it contains the vote, whether it is even or odd. I will explain once I get to the UI. And the proof. So the proof is struct containing elements A, B, C that make up the ZK snark proof. So if you see the structure of a ZK snark, it contains 3 points, A, B, and C. So yeah, this is how it is defined. And you can take it from the library itself, so no worries on that. So we have reached here, like we generate the proof. Um then the scalar snark scalar field, which basically represent the upper limit for value in the zk snark. As I said, it is only used when the size of the proof is small, right? So yeah, basically it ensures the limit and then retrieve from the verifying key. So the verifying key, like basically obtained from the verifying key here. Yeah, here. So these are the keys, like I've taken it like pairing. You can get it from the library itself, there is no issue on that. So yeah, and once you just a second, yeah, and then the input verification length, the statement like ensure that the length of the input array matches the number of element expected by the verifying key. So if there is a mismatch, the function reverts and preventing potential invalid or tampered proof. So yeah, uh, so yeah, this is basically done. So the pairing check is done. Basically here, these are the pairs, as I said, like the for each point, and this is all. I You can get it as well, and you can generate from the library itself. So and this basically verifies the proof, and yeah, basically this is the length. I've not defined it. Like I just took it from the zk snark value, and it basically generates the proof from here. And yeah, this basically generates the transaction. And uh, basically this is the contract, which is the most important contract. So if you ask me, what are the things like alpha, beta, gamma, delta? So in zk snark, these are the parameters generated during trusted setup phase. So these elements are used within the verifying key and contribute like to the verification process. And yeah, the elliptic process, elliptic curve, which is is the type, like it's a mathematical curve. So basically it's used to construct public and private key. This is not in our scope, like to derive or things like that. The G1 and G2 which we use, so these are basically specific of points on an elliptic curve. So this is automatically generated. And yeah, so this basically project demonstrate how you can easily use any library and make a project on top of Taiko to make a like a anonymous voting system. So like these are the basically contracts. These are already deployed and I've defined in my environment. So yeah, so this is it. Yeah, so yeah, basically what it does is the flow is, so it enables user to cast a vote for either even or odd, so without revealing their choice or identity. So yeah, basically what the contract does is like so basically the structure is represents a point on an elliptical curve, as I said, G1 point, and G2 point is representing a point on an elliptic curve on G2, and the P1, it returns the generated point of P. Basically, if you know the linear equation, like y equal to mx for c plus c, where c is a constant. So for every y you get a x, or vice versa. For every x you get a y, right? So yeah, so this is how the contracts are done. So so yeah, these are the things basically in our scope right now. And yeah, so so if we, let's say, start np yarn, I've already installed on the things. And if you do yarn run dev, and if you go to localhost, uh, mm, yeah. So see, this is the UI, very simple, nothing too much discuss. That's why I did not discuss the UI. So these are the things because already I've been testing before presentation. So these are the things. Let's say you add an input three, right? Three is an odd number. So let's say I voted. Let's say I vote here, and yeah, it asks to sign a transaction, and yeah, that's it. If you go here, it will actually say contract introduction. It's a free transaction because on Taiko you don't need to, it's very cheap on mainnet and testnet both. So yeah, see, if you go here, it's a success, and on odd, the value increased by one. Yeah, by one it increased because we voted for odd and it gives you the transaction. But no one neither took an input here in the contract. If you see, there is no point for any input, right? Where I am taking input, neither in the UI. So no one knows what you actually what you actually gave in input, right? So yeah, this is the whole thing. Like, let's say if you take 420 and 42, let's say, and let's say you give a transaction. So it takes a bit of time, and yeah, it basically in within seconds it actually confirms the transaction, and it will increase from 5 to 6. So yeah, it's done, and here it will actually get the value. Just a second, it's getting fetched. So yeah, okay, it was actually 4, so it increased to 5. So yeah, 6, sorry. So yeah, this is what actually is, and no one here knows what you actually gave in input. It just interacts with the contract, the proof we are using, and yeah, that's it. And like with this, you can do a lot of things. Like, you can make actually an election system. For example, here there are two parties. Like, let's say Kamala Harris and Donald Trump. No one knows apart from you or anyone else, and never will know, and it does not fetch as input anywhere. So in a secure and private way you can actually vote and do the things. So that's the whole project all about. So I just, for a kickstart, I just use this library which actually contains all the things. You don't need to do anything, just need to actually run one command and everything will be set it up. And I just showed how you can do for a number. Yeah, quite short, but I think, yeah. I think Jorin is here, or
Hey, all done already?
yeah, this was pretty short. So like, I used a library and generated things, so nothing much in context. I just explained the contracts and things like that.
Gotcha. Okay, well, yeah, I think that that's very useful for folks to see how like ZK technology works in action, and we'll be able to share this repo with the community so that they can take a look at them for themselves and maybe incorporate it into their projects. And if they have any questions, they can find you over on the Discord. There should be a link there for you guys. If not there, you can also look on the DoraHacks page. All of the details for the hackathon are there. Our contact information is there as well. Let's take a look here in the comments. We have some new faces in here, so it's always great to see new people joining in. People talking about just starting a new project. That's amazing. A lottery application. So ZK technology might be useful in that use case. I'm not aware of anybody building a lottery application, but it's quite possible that we haven't seen the submission come in yet. Yes, we will. Otuku asks if we're going to share the repository. 100%. Come on over to our Discord, and you can get the link for the repository. It will also be eventually attached to the video. But if you want it as quick as possible, come on over to our Discord, and we'll be able to help you there. Oh, okay. So yeah, the two new faces I saw are working on a project together. There is a question from Wants to Comment. Thank you for the comment. Thank you for the question. Is there any advantage of using ZK proofs on a ZK EVM?
Yeah, definitely. I think like advantages of basically ZK EVMs is basically it increases the transaction throughput, I guess. Yeah, while because there is no network congestion on that, so I think it's always beneficial. But I think for a project like I'm so sorry, for a hackathon level, I think it does not make much sense. So I think you can use any VM. In fact, if you use ZK Snarks, right? So that will anyway make it more faster or things like that. So yeah.
Nice. Yeah, I think that's all the questions that we have from the community, all the questions I have personally. Yeah, so thank you so much, Swarna, for giving us another amazing workshop and closing out your series of 4 workshops with this amazing one. And yeah, we'll see you guys over on the Discord. And yeah, Jan, do you have any closing words for us?
Yeah, so like, thanks a lot for your great presentation. It's also, or like always, super interesting to learn more about voting, anonymous voting, like what can be implemented. And I just wanted to say thank you for this incredible workshop. So there will be more workshops on Monday. So see you guys on Monday.
Perfect. Thanks, everybody.
Thank you, guys.
Thanks a lot. Yeah.